In this video, we will talk about scopes and namespaces, local and global variables. In the previous video about functions, I mentioned the local variables of that function. I said that parameters of a function are its global variables. And when we are passing arguments into the function, we assign a new values to that local variables. Let's check it in practice. Let's create a function. For brevity, I will name it just a. It won't accept any arguments, and in the body of the a function I want to call the print function and pass into it the call of the locals function as an argument. Almost like at the end of the previous video. Here is the same case of the sequential call of functions, that is, the result of one function becomes an argument to another one. The locals function returns us a dictionary that contains names of local variables and their values. We will talk about dictionaries later, but for now I want to simply mention that dictionaries is a data type in which data are stored as pairs, like in your phone book. You can find the phone number of a person by his name in your phone book. That is, in dictionaries, there are some keys that play roles as identifiers and associated with that key's values some data. And if I call the a function, then we won't see anything, since the function has no local variables, empty dictionary. So let's add a parameter to the a function definition, let's say the name parameter. And when we are calling the a function, we have to pass into it some argument. Hello world, for example. And let's run the code again. And we can see the results of the work of the locals function, a dictionary where our name variable got a value hello world string. And thus parameters of functions are the local variables. I am defining a new name variable and assign to it John string as the value. And right below it I want to define the name variable again and assign to it a different value n, for example. And let's print the name variable. And now the question is, what is the value of the name variable? 3, 2, 1. Obviously that's the value of the name variable is n, since n value was the last one assigned to the name variable. If I run the code, we can see it. And if I swap the names, the results will be different. Okay, let's move on. Now I want to move John name into the body of the a function. Let's uncomment it and let's move it here. Without arguments, and I am calling the print function with name this way. Name the function that has the name John, and I am printing the name variable. And again the question, what is the value of the name variable? 3, 2, 1, and the value of the name variable is n. And why is the value of the name variable is n but not John? After all, the John value was assigned last. Why so? After all, also these variables have the same name, and in theory the second assignment of a new value to the name variable should override the old value with the new one. That is, it seems to be John. But no. The name variable should have n value because the second name variable, which is defined inside the a function, is in a different namespace, and all namespaces are apart and independent from each other. Along with the concept of namespaces in Python, there is the concept of scopes. They are similar, but they are not the same. Let's start with the namespaces. The namespace is a dictionary, the same one that we already saw when we called the locals function. I want to add to the a function the call of the locals function again. And as I said, the locals dictionary contains information about names and their values, and let's call the a function. And let's run the code. And here we can see that there is the name key. It's our name variable, and its value is John string. When we make any assignment, we change the namespace. That is, we change the content of the locals dictionary in which there is a mapping of values to specific names. Well, for example, let's add one more variable. Let's say the age variable, age 18 for example, and let's run the code again, and we can see a new name and new value. That is, the content of the dictionary has changed. And now I want to show that the contents of the locals dictionaries of the a function and the global scope, that is, of the level at which the a function itself and the name variable are defined, are different. To do this, inside the a function I want to set a label as an explanation. For example, here and also before the call of the a function I want to call the print function without arguments to print an empty line as separator. And let's run the code. There is a dictionary of the global external namespace. Note that at the external global level there is the a name with which a function object is associated, and the function object is located at that memory address, and accordingly the name variable has the value n. The locals dictionary of the a function is very modest, contains only 2 names, and the name has John as the value. Okay, how does Python figure out which namespace, that is, in which dictionary it should write a specific name and its value? To a global dictionary, to a local one, or to what else? It's very simple. The place where assignment is performed determines the namespace in which this name will be located. I mean the name of a variable, a function, or a class, it doesn't matter. Along with defining the namespace, Python defines the scope accordingly. What is the scope? Before I will answer this question, I want to change a few things in this code. Let's rid of the age, let's print the name, and just call the a function. And if I run this code, the call of the a function will print the value of the name variable, John. The scope determines in which namespace Python will look for a name definition and in what order it will search. To determine the search order of names of variables, for example, there is a rule with the abbreviation LEGB, local enclosed global built-ins. Local, it's a local namespace, a local level. Enclosed, what is it? The nesting of blocks of code can be quite deep. Here we have only 2 blocks, the local and immediately the global level. But if we have, let's say, 3 levels of code blocks, roughly speaking 3 levels of indentation, but it's not quite right, Enclosed namespace is one notch higher than local, but not global yet. Then is the global namespace, the level that has no indentation. And finally, built-ins. It's built-ins module level, which is implicitly imported when the interpreter starts, and which contains all the built-in types and functions. The functions like print or dir or locals and so on are defined in the built-ins module. We can use them right away without any importing. Okay, now we need to check it out. To do this, inside the A function, I will define the B internal function and call it there. Python allows us to do it, and don't let this bother you. I just need one more level of nesting, and that's all. Def B name will be John here. This name will be, for example, in A. Then I want print name. Then I have to call the B function. And I'm calling the A function here. So I have here three name variables defined at different namespaces, N, in A, and John. I'm going to briefly explain what is happening here. I defined the A function, then I called it. Python began to execute the A function's code. That is, Python creates the name variable with the in A string as its value, then define the B function and call the B function. Calling the B function starts execution of its code. That is, define the name variable again with the John string as the value, print the name variable, and print the locals. I run the code and we can see that the name variable with the John value is printed. That is the one name variable that was declared in the B function, and it is the local namespace. Let's comment this name and let's run the code again. Python has been instructed to print the value of the name variable. And Python began to search the definition of the name variable in the local namespace. He couldn't find it in the local namespace, so he went up to the enclosed namespace and found the definition of the name variable here in the enclosed scope. Therefore, we got the in A message. And again, let's comment it's out too, and let's run the code again. And the Python printed the value of the global name variable, the N. He didn't find the definition of the name variable neither at the local level, local namespace, or at the higher level. He found only at the global level, and he printed it. By the way, note that the locals dictionary is empty. And finally, I want to comment this definition too. And what do you think will happen? Python won't find the definition of the name variable in the local namespace, it won't find its definition in the names of the function A, and it won't find it globally in the global namespace. Then it will go to the built-ins level, but it won't find that definition there either. And Python will raise an exception that the name variable is not defined. Let's run the code, and this is the exception. Name is not defined. The scope determines in which namespace, that is literally in which dictionary, Python will look for a particular name and in what order it will look for it. The scope of any variable starts from the local namespace and goes out like on steps until it reaches the global level and then to the level of the built-ins module. When we say that the variable name is in the namespace of the function A or B, we mean that it's defined there it's defined locally inside a function or any other block, a loop for example. When we say that the variable name is in the scope of a function, for example b function, it means that the name variable is either in the namespace of the b function, or it is in the namespace of the a function, or it is in the global namespace. Whenever we declare a function or other block, we create a namespace and a scope. A namespace is a dictionary of names and their values. Scope is a chain of namespaces that starts at the local and continues up to the global or built-in level. Often these concepts are used interchangeably, but only because they largely coincide and the same thing is meant. Sooner or later you would have a question: what is the difference? Why do we need namespaces? In fact, it's a defense mechanism that helps to avoid all sorts of name conflicts that would inevitably arise if this mechanism did not exist. I think we will come back to this a little bit later when our examples become more complicated. But do not rely on me in any way. You need to experiment and to try to follow this logic. The next video will be about the conditional if statement and the Boolean data type. If you like the video, please leave a like and subscribe to the channel. Thanks for watching.